Okay, so officially, I would like to welcome you to the first panel of the streaming stories, and I'm super thrilled to have such a stellar lineup today. So we have with us today Zhenzhong Xu, co-founder of Claypot AI, organization that focuses on solving real-time ML challenges. Zhenzhong has been in the stream processing space for over 10 years. And he started, and he was previously building real-time infrastructure at Netflix from scratch, growing use cases from 0 to 2000. Welcome, Zhenzhong.
Thank you.
We also have Mike Rosam, co-founder and CEO at Quix, where he works at the intersection of business and technology, pioneering the first streaming data development platform. And previously, Mike was the head of innovation at McLaren Applied, leading the data analytics product team. And finally, we have Yingjun Wu, of founder and CEO at RisingWave Labs. Before starting RisingWave Labs, Yingjun worked as an engineer at Redshift team, also Amazon Web Services. But he also had an academic career working as a researcher at the database group IBM Almaden Research Center. Welcome, everyone. And let's maybe jump into the discussion now. We have so many questions. So perhaps we should start by dissecting the current state of the market. And like, we haven't really set up the order. We can go like alphabetically, or perhaps like you just can like start answering like to your liking. But let's start maybe with the first question. How do you see the state of stream processing in 2023? Zhenzhong, you can go first.
Okay, so we're gonna start alphabetically. You know, I feel like I was saying.
Okay. Mike, go ahead.
Yeah, well, I can share some of my thoughts first, and maybe we can, exchange ideas and maybe challenge each other a little bit here on this topic. I do feel maybe there's multiple different perspectives on here, right? So, in my, years working with stream processing, I feel like, there has been a long history of changes, right? So, initially about 10 years ago, I think right around 2008, right? So there was a poker boom in United States. I don't know if you guys know about it, right? So all my friends was playing poker, especially online poker. They were really good at it. So that actually got me really interested in, kind of trying to figure out real-time decision-making by, looking into large amount of the data, right? So, but back then the technology wasn't there. We were using SQL Server, we were using, cube technologies, right? So we're trying to fit like 1 billion data inside a cube and to do real-time analytics. It just doesn't work. That was the state of art back about 10 years ago, right? So fast forward to today, I feel like, stream processing engine technology is definitely getting more mature, right? So, Apache Flink is one of the engine that's well known. The ecosystem around that, for example, Kafka, right? Also, maybe about like 7-8 years ago, there was an article talking about turning database inside out, right? So I think this stream processing technology is really nothing more than, essentially kind of turning a single machine database technology into a distributed, database technology, and stream processing is one part of that, right? So that piece of technology is really getting more mature over time. So in 2003, I would expect there's going to be a lot more development around, integrations. For example, integration with upstream, with client, with, on the edge, right? Also integration with downstream, with data warehouses, especially the second generation data warehouse like Iceberg, Hoodie, Delta Lake, things like that. There's also going to be work around, abstraction layer, right? So one of the challenges around stream processing today is it's extremely hard to use and operate as an infrastructure engineering team, right? So, how do you make that easy for ultimately the end users while, maintaining the operationality for, whichever team is going to maintain the infrastructure? I feel, those are going to be the interesting things that make stream processing more popular over time. Yeah.
Okay. Who feels the same way? Mike,
Yeah,
do you
I
want
think this
Yeah.
certainly, yeah, this year's feels very exciting for streaming data. It's been around for a while, and of course there has been a lot of early adopters, and you can read about many of them that are also on this call. In fact, all of us really, back in 2016, we were deploying Kafka for real-time processing in Formula One. Now it's becoming much more mainstream. I think even in the last couple of months, you start to see a lot more activity in startups. There's more people trying to fill some of the gaps that are there in streaming, and these things like usability and the abstraction layers. And yeah, so I really think it's coming. Although I do actually see it's also still early. You can go and speak with large and small organizations, and they're just testing the water with some of these technologies. So I think really this decade is going to be all about streaming, and probably, we're in 2023, we're a third of the way through it. So maybe, yeah, it's like 30% hot, but it's going to be really hot by the end of the decade.
Mm-hmm.
Your thoughts, Yingjun, on this?
Well, I have to say that it's probably one of the best time in our history for stream processing. So I started working on stream processing around 10 or 11 years ago. And at the time, there's no Flink. Actually, Flink just started, okay? There's and it was still called a Stratosphere, right? And which was actually a research project at TU Berlin. And at the time, what we saw is that people were building their applications on top of Apache Storm, and and some of them are building their own stream processing system using the technology similar to MapReduce, because they think that MapReduce is great, and we can probably build the stream processing technology in the same way, in the same paradigm, right? We can use a MapReduce to build stream processing technology. And actually, around 2015 or 2016, I feel that probably there's no novelty in this domain, because since from 2010 to 2015. People keep working on the building distributed stream processing systems, and I find why everyone is building this, and there's no novelty here. But for the interesting thing here, that what we found is that since 2015, people are moving from their big data center or their own in-house cluster to the cloud. Actually, this gives a huge chance to the stream processing technology. It actually gives us a chance to rethink what we want for stream processing technology. And that's why I feel that it's definitely a very good time. And over the last 3 years, I founded this company 2 years ago, and in 2020, Snowflake got an IPO, right? And what we found is that since that, people are talking about should we move from batch to stream processing? Should we move from batch to streaming, right? Mm-hmm. And that's definitely one of the best time for us, right? Since that, we saw that a lot of people are shifting their attention from the data house to the streaming processing technologies, and that's why I feel that definitely one of best time.
Totally. Yeah, I really feel, the adoption curve of early adopters, early innovators, and then you've got the late adopters and the laggards. The big warehouse market is definitely in that late adopter entering the laggard space. And I think the early adopters are now moving forward with streaming. So that's where you're seeing the exciting energy.
Yeah, definitely. And actually, for those who are big vendors, data warehouse vendors, they're also trying to build some stream processing capabilities inside of their data warehouse, right? For example, the Snowflake, for example, Redshift. They all claim that they can do streaming ingestions. Yeah, definitely.
Yeah, and totally. And Databricks, they got Project Lightspeed, so I think they're trying to reinvent Spark to make it a bit more real time than Spark streaming was. So yeah, of course, you're going to see the big players also coming into that space. But I wonder if it speaks to best in breed and avoiding vendor lock-in, that kind of thing. So we'll see if they manage to capture a lot of streaming market share, or if our kind of companies are going to be able to innovate faster and do more interesting things.
Yeah, Actually, one question for you is that okay, probably it's not included in the question list. So one question for you is that how Quix is different from Spark streaming, because I know that they can also do Python, right?
Yeah, so we actually built new IP. So yeah, there's a complex landscape of streaming engines. You've got Spark, you've got Flink, you've got K-Streams, KSQLDB, many other streaming databases coming out now, like RisingWave. Quix is actually built on top of Kafka libRd. We're trying to build, or we are building, a library which is between K-Streams. So it's lightweight, like K-Streams. It's easy to use. You can run it anywhere. But it's got the power of Flink. So it's got some enhanced features like support for different data types. So there's specific support for time series data. It's got specific support for large data files like video and audio and other large data payloads. And it's got specific a specific like state management solution, which unlike K-Streams doesn't use Kafka as intermediate topics. It's much more like Flink in that it's state-backed state management solution, blob storage-backed state management solution, leveraging the Kubernetes PVC. So it's actually more of a cloud-native solution. Of course, it's early. We've literally just open sourced it today. By coincidence, it's 3 years since we founded Quix on the 2nd of March 2020. And we've open sourced this library today. And it's still early, but we've got a clear framework for building a next-gen kind of a next-generation streaming engine.
Awesome. We'd love to check it out.
Yeah.
I actually have a couple of thoughts between Spark streaming, Flink, all the different engines. I feel like there's like two main ecosystems around stream processing, when people typically talking about evaluation, right? So Spark streaming, I feel like a lot of people can ease into use Spark streaming if they are already on the batch, Spark ecosystem already. That's a very easy process to move into that. A lot of people choose to do that. But over time, I think, Spark stream processing is also limited by some of the underlying kind of design principles. And, originally, the RDD design was great in terms of doing Spark, but it becomes a limiting factor for the stream processing aspect of things, right? So, I also feel, some of the development in terms of resilience, fault tolerance is probably slightly behind Flink. Obviously, there's also, the third, I guess, I don't know if it's called generation or category of stream processing engines that, kind of following the new approach, like in terms of a database materialization. I feel, that is a little bit more kind of upcoming, maybe the third generation or second generation engines there. Not going to tap too much into that, but for Flink, I feel like the strength is more maturity, right? So the underlying the state management, the fault resilience, the distributed processing, all that kind of stuff. I would love to hear a little bit more opinion from maybe Yingjun, around the second generation or third generation of the stream processing engine here. How do you see the major differences?
Well, yeah, definitely. That's a great question. So I have to say that okay, Spark streaming and Flink are definitely the top two streaming engines for in the over the last 10 years, right? That were built over the last 10 years. And but what we found is that okay, so for Spark streaming, I mean, if people just want to use, I mean, between these two systems, okay. If people just want to have a stream processing engine, or if they just want to pick one system for stream processing for their stream processing applications, then people will pick Flink, because people will think, okay, I mean, Spark streaming is not ideal for stream processing because the latency is pretty high and it's pretty heavy. Because what if I do not really use Spark? Right. So that's why people probably will only choose one single system, which is Apache Flink. But what we found is that okay, I mean, for most of the companies, if they choose Flink, then the problem here is that okay, they have to manage the Flink on their own, and they actually have to hire a group of engineers to maintain the system, which can be quite complicated, which can be quite expensive. Right. If you check, well, okay, so think about it. If you want to deploy Flink today, And what do you want? What do you need to do? You probably need to check the Flink's website, and you probably need to learn a lot of concepts about, okay, what is state management, what is fault tolerance, what is resilience, right? And what is Flink API, right? Or Flink Java API, data stream API, or data table API, right? Yeah, but though Flink's Flink SQL interface lower the bar for using Flink, it doesn't really mean that it avoids all kinds of the maintenance costs, avoids all kinds of learning curves, right? Well, it avoids all kinds of the operating costs. It doesn't really do that. So what we found is that for the new generation, I think that it's definitely a good trend. A major trend is that we definitely want to lower the bar for people to use the stream processing technology. And second thing is that people should not think too much about how to scale in and scale out. And definitely the other key issue here that what I feel that people care more about the cost efficiency, probably because of the economy, right? Where the economy is not good, right? So everyone knows that. So people were, when people are adopting a new technology, they're probably one of the first few questions they will ask is that, well, how much money I should pay, right? For Flink, well, it's to be honest, well, it's not that cost efficiency because of our reasons, like its Java interface, or because of its how it manages states, and because of all these kind of things. But it seems to give us chance. I mean, us like RisingWave, like probably Quix, right? Or like some other companies, a chance to build a system that is more cost efficient and more simple to use. Yeah, that's my view.
Awesome.
Totally. I mean, also the things like the JVM, right? It's you either love it or you hate it. It's definitely Marmite, especially from a developer experience where you're basically with Flink injecting code into clusters. It makes life pretty hard for debugging, which further increases the challenges of actually building a real-time application. So there's lots of nuances to your tech choice here. I presume you've seen Confluent acquire Immerok recently, and there's actually 1,000. There's 1,000 managed Flink vendors seem to have popped up everywhere. I guess somebody's going to solve managed Flink at scale, so the operational burden of it won't be there. But maybe there's still going to be a developer experience challenge around it.
Yeah, in terms of debugging, well, we actually have a customer told us that they used to use Flink. They told me that they actually use GitHub to manage the Flink. Well, I mean, because that for Flink you have to upload the jar, right? They probably don't really want to do that. So they actually, every time they want to commit a new job, create a new job and submit a new job, they actually use GitHub. Because once you commit, well, it will trigger a CI/CD pipeline and it will help you to deploy, which actually feels weird, right? Because why do you use GitHub to deploy the code, right?
Yep. Oh, actually, I resonate to that a lot, like in terms of using GitOps for managing the operation and deployment, right? So, in our company, we actually use something called declarative reconciliation to enable, as users, you declare your features and check into GitHub repository, and on the backend, we'll automatically reconcile that and deploy that and manage all the operation for the user, including auto scaling, deployments, all that kind of stuff, right? So I definitely do agree. One of the challenges around, making stream processing more popular, more available, is you have to make it, make the interface invisible, so people can, similar to like plugging electronic devices into the wall, right? So it's similar. Stream processing engine here is a power. So how do you enable, applications to be able to have that plug and play sort of opportunity? So really, the interface or abstraction layer needs to be like super invisible there. I also want to touch point on one of the challenges you guys also mentioned around cost and optimization, right? So I feel like, given the stream processing engine is kind of specializing towards different, dimensions or strengths, for obvious reason, every single stream processing engine actually kind of builds on different data structures, different assumptions, optimized for different reads and writes, all that, right? But given that, sort of a specialization in different engines, and for somebody who wants to kind of leverage, maybe both batch engines and stream processing engines, right? So there's going to be this kind of analysis and evaluation on different evaluations and optimization, or maybe even having the ability to kind of leverage both engines at the same time, right? given different scenario. Even in the case where maybe for a single engine, maybe depends on the actual use case scenario. For example, if you have a large window with more granular kind of emits versus smaller windows with less data. So in order to achieve the same result, the underlying windowing mechanism might be different, right? So some of this, if we're talking about actually having a data scientist as an end user for some of those stream processing engines, they might not actually know all the nuanced details, right? So they are not actually the developers who develop the engines. So how do you make that API, more available? But also ultimately, do you guys also see maybe an opportunity for like intermediate abstraction layer, either on top of the engine or maybe within the engine that performs maybe optimizations towards different use cases, and also eventually kind of compile that into actual workloads, right? Flink SQL does that sort of to some degree, but out of curiosity, how do you guys see in that space?
Can I just step in for a second?
Yeah.
I mean, this is like really great discussion, and like maybe can we like time box some of these things that we have been like discussing? For example, maybe can we like ask ourselves like what would be like the most immediate development and challenges, like something that we are expect to see like this year of the things that we have discussed, and what is something that we expect to see in the next 5 years? Like, for example, what are the key problems that are going to be solved, like just to kind of have it like short term and long term.
Well, I think Zhenzhong's question is pretty good, and actually it helps answer your question. So because it's more about the abstraction, right? Well, I mean, it's definitely one of the major things that we will foresee in next, I mean, this year or probably next 3 or 2 years, right? So there are essentially, I think that there are two things, or the two questions. One is about the API or the interface, right? What kind of interface you can provide to the users, right? And actually, the other question is about how to achieve the cost efficiency, right? That's definitely one of the major questions people care about, right? Especially for this year and for probably next year and the year after next, right? So yeah, so from my perspective, I mean, for SQL, I think for SQL is powerful enough. For example, Zhenzhong mentioned, okay, window function. Essentially, I mean, you can process window functions using SQL, and we actually just supported the Python API, which means that Python UDF, which means that if you have if you want to use Python to express your logic, you can do that, because anyways, it's you can write in UDF. And about the cost efficiency, I mean, several things. Well, the first one is that about if you want to deploy the system in the cloud, then a major challenge here is that how can you guarantee that it doesn't really consume too much money, right? Well, it doesn't really consume too much cost. So what do we do is that we use the decoupled compute and storage architecture, decoupled compute storage architecture, which help to reduce the cost, because in this way you can scale in and out the storage and compute separately and infinitely. That's one thing. And the second thing is about, I think that's how a streaming database like RisingWave is different from a streaming engine like Flink. That is the materialized view. So think about it. If you have 1,000 jobs if a company really want to manage 1,000 Flink jobs, then it probably needs to manage 1,000 machines, right? For every single machine, you probably need to manage you probably need to run one job, right? But if you have the ability to maintain the materialized views, it means that you can essentially share the computations across these for 1,000 jobs. Probably you can just create, let's say, 100 materialized views to manage all these 1,000 jobs, right? Or even in some extreme case, probably just one views for all these 1,000 jobs, right? So essentially, the cost can be dropped exponentially. So that's what we did. So in RisingWave, yeah. So, yeah, Mike, You have any?
Yeah, I mean, the efficiency opportunity, I think, is actually moving from workloads in your database to your warehouse onto the streaming architecture. So I think it's called Kappa architecture, you know, streaming first, whatever, build a streaming ingestion pipeline, go upsource, fix data quality problems, process data in flight, deal with it, handle it, use it in your business, like route that data back to your product. I mean, I get super annoyed. All the data architecture diagrams always flow from like left to right, where data starts at a source and it ends up in your warehouse. No, data should end up back in your product, right? That's how you get the most value out of your data. And I think you see companies spending huge amounts of money on big warehouse compute workloads, sucking data out of warehouses, you know, transforming it, sticking it back, doing all of this work. And a lot of that for what? It's just a cost center on your business. Whereas I think if you move to a streaming first workload, we see it's very, very efficient using a technology like Quix to process a lot of data in flight. And you can basically use quite small Kubernetes compute clusters with Kafka and Python, process that data on the way in. And if you compare like a simple streaming ingestion pipeline to something like Fivetran, you're probably going to be paying a fortune for a few events or a few, you know, 100,000 events. God knows, guys, what does Fivetran cost for, I don't know, 1 million events? I tell you, to do 1 million events on Quix is probably going to cost you a few quid. It's like really, really efficient. And I think companies are going to realize that the old kind of modern data stack is a big, expensive, complex and vendor locked in architecture. So yeah, if you can leverage a couple of core building blocks of modern software infrastructure, as I mentioned, like Kafka, Python, Kubernetes, you can build streaming pipelines, and you can save vast sums of money on your overall infrastructure bills.
Yeah, I would like to maybe. Oh, sorry. How are you doing on time? Actually, maybe a couple quick minutes here. So I would like to maybe adding one extra point here. I think, you know, sometimes maybe cost optimization also includes optimizing for human time, right? So, you know, maybe let me take a concrete example here. So for data scientists, today their workflow is to, you know, develop models and experimental features locally by, you know, having the data engineers to, you know, maybe query the data warehouse and send over a CSV. That's their typical workflow today, right? There's huge gap in terms of kind of doing local experiment to, you know, moving things into production, right? So, you know, I think obviously a lot of data scientists are looking to doing stream processing, but there's a huge barrier because of this. You know, they have to work with data engineers, machine learning engineers to be able to move into production. So sometimes, you know, having a stream processing engine, you know, to be able to, you know, support moving local experiments to production use case in a simple fashion, that also helps a lot, right? So maybe concretely from a technical point of view, right? So when you do local experiments, you also expect to get the data from data warehouse and be able to, you know, do processing locally extremely fast. We're talking about a very different scenario here. Here is, you know, a single machine, maybe memory optimized, you know, maybe you want to leverage like a vector processing, like, you know, for example, in Intel CPU, there's something called SMA, single instruction, multiple data, to enable you to do that extremely fast, you know, processing. That's also real time, you know, but it feels more like a batch, right? When you want to kind of push that into production, I think data scientists actually kind of face one challenge here is they either have to re-implement the job in a different language or a different framework, or they have to work with another, you know, data engineer to kind of push that into production, right? So the challenge here also remains about that interface. Can we having the data scientists to implement a single declaration, whether it's in SQL or Python, right? But it works across different engines. For example, in this case, local experiments will be pulling data from data warehouse, but, you know, using Panda data frame or, you know, Arrow or DuckDB for local processing. But when users actually ready to push into production, the same declaration will actually work exactly the same as in, you know, a backend, maybe, you know, using you know, Flink or Spark streaming, you know, things like that. So I think, you know, there may be also some opportunity in that space in terms of distributed, you know, optimizations and compilation. And maybe coming back to, you know, Mike's point, right, around, you know, pushing some of the processing upstream. I think, you know, there will be cases where, for example, if you have lots of data flowing through your pipeline, but your feature engineering or whatever pipeline engineering you're looking at only process a small percentage of that data. So why sending all the data over? Why can't you, just kind of pushing that process into the client side? So that is also part of the opportunity here as well. Yeah.
Okay, guys, can we tackle now like batch versus stream? I mean, like we were getting like a lot of questions obviously on that. So how do you feel about like unified batch and stream processing? Will that be the main trend? And do you think that like there is a possibility to replace batch processing in some use cases? Which use cases? And finally, we have been asked this a lot, and I'm sure like our attendees are eager to hear this. Will Apache Flink dominate the future, or what would be like the alternative?
Great. Yeah, very interesting. Batch and streaming, absolutely. Yeah, they need to converge. They are converging. They need to converge. The issue is in the details of what you need to do to move to streaming. So you'll hear all of these points about partitions and checkpointing and like node balancing and all this kind of stuff. Who cares about all that kind of stuff, right? When you're running batch on a table, you just run a query across a table and you get a result. Super easy. It's like a very, very easy thing to do. You don't have to worry about checkpointing the state because that table's not evolving. And these are the details which actually make streaming hard from a developer perspective. And I think more work needs to be done in order to basically take them off the table. Like you can work in your Jupyter notebook and copy and paste that code into a streaming environment and it just runs. That's probably the holy grail of where the industry needs to get to. At that point, everybody should be using it because it's kind of a superior technology. It's more efficient, it's more responsive. There's lots and lots of applications where you could use a streaming workload. And I think it's going to happen pretty soon. Of course, you still want batch workloads. Super good for analytics, really good for BI, and you need to separate and build an architecture where you can do both streaming and batch together.
Thanks, Mike. Anyone else?
Yeah, my thoughts on that. So first of all, I think batch and streaming. That's an artificial term we actually define as a developer, right? So from the actual user's point of view, they don't really care, whether it's actually the batch engine underneath the hood or streaming engines. But from a technology point of view, right? So the move from batch to streaming is inevitable. It's one-way street, and here's why, right? So at Claypot, we actually work on a lot of the optimization. Essentially kind of breaking down the actual processing workloads into operator trees, like intermediate representations, all that kind of stuff, right? So one of the challenges we notice is, for a batch workload, there's no time semantics, like windowing, watermark, right? As Mike also mentioned earlier, some of the resilient stuff about like chip points, all that kind of stuff is just non-existent in the batch world, right? So that means, the added time dimension makes the move from batch use case to stream processing possible because you're adding a new dimension in there, right? But moving from once you actually kind of started using some of the windowing semantics and watermark, it becomes impossible for you to move back. So purely kind of from conceptual point of view, it's a one-way street in terms of a kind of move from technologies. And there's also things that are much more superior from stream processing perspective, compared to batch. I take one concrete example here, right? For example, one of the challenges in maybe machine learning around doing training data set generation is actually you have to do a point in time join, between some of the features and impression data, right? So maybe an example here, it will be, let's say Netflix actually shows all those recommendations to you. So once a user actually views the recommendation and actually click on one of the movie, that's one impression, right? So the impression about the recommendation is one impression, but when user click on the movie, that's actually the action results. So the impression, we want to, join that with, the actual feature that's, relevant to at that point in time. So that requires you to do, point in time query joins, which is a very complex process because, when the feature is being generated, you want to join at the time of the inference, but maybe the feature wasn't available. So you have to kind of look maybe right before that, what's the latest feature for doing that, right? So for do this type of join, when you have the left-hand table, which is the impression table, and right-hand table, which is the feature table, the complexity for doing the join is for every single row in left-hand table, you have to scan through the entire right-hand table, right? Which is extremely, slow in terms of, the join complexity there. So how do people actually solve that, right? In the batch world, you use partitioned, bucket join. So essentially you bucket the right-hand table and also the left-hand table using time. But the typical partition size will be 1 hour, right? So that means, you can limit the amount of join complexity within the 1 hour window. But even though it improved a lot, it's still quite a bit of a complexity and overhead, right? In streaming side, what's nice thing about streaming is you have watermark. Now you have more granularity than just the 1 hour partition. You can go down to maybe minutes, even seconds to do that join. So it becomes much more efficient. Now with a lot of lateness or things like that, which makes your join capability extremely fast, but at the same time also give you lower latency and higher freshness of your kind of join capability as well. That's just one example. I feel like it's going to be inevitable, and I would love to see that happens more as well.
Yeah. So yeah, regarding the unified batch and stream processing, well, I have to say that definitely a lot of people are talking about this, but the current situation is that people are still using some streaming processing engine and separate stream processing engine and a batch processing engine, right? Probably they use Flink for stream processing and probably use Spark for batch processing. So why this happens? Well, I think one of the main reasons here is that so these systems, it takes time to build a solid system, right? I know that Flink is also building their batch engine, and the Spark streaming is Spark is also trying to build the next generation Spark streaming, right? A better streaming engine. It takes time, so we probably it's not really easy for us for them to build an engine within just 1 single year, right? Well, it will take time. It will take time, but definitely, it's definitely a trend. However, I would also say that it's there are also challenges to unify batch and stream processing, because so several reasons. The first one is that not all the so people may care about, in some cases people care more about the order processing. For example, in the finance, in the fintech, or in some, let's say, the IoT cases, right? They care more about the data arrivals, right? Because they want to make sure that the result is always correct. We cannot tolerate any incorrect results, right? So if you are dealing with that case, probably you still need to have a stream processing engine, right? Specialized stream processing engine. And for batch processing, not all the one of the challenges here that not all the expressions can be done incrementally, because for stream processing, the instance of stream processing is incremental computation, right? But not all the expressions can be done incrementally. So essentially, at the end of the day, if you want to unify the batch and processing, essentially you will have to build 2 engines, but you will somehow, somehow probably you can stitch them together, right? Using some kind of, right? Because we're in the cloud, nobody will see what's happening under the hood, right? You can do that, but technology-wise, it really is super hard for us to develop a single engine that can satisfy both streaming and satisfy both stream processing and batch processing. Yeah.
Any more thoughts on this, or can you just tell us what industries will benefit the most, in your opinion, from stream processing? And do you think stream processing is going to be critical for machine learning short term?
I think Zhenzhong is probably one of the better person to answer the machine learning question, right? Because we're learning here.
I definitely do have some thoughts around that. I feel like, in the past decade, machine learning has kind of gone from, maybe not just past a few decades, gone from small machine learning scale to extremely large machine learning scale today, right? So, but a lot of the use cases was able, companies was focusing on more, kind of focusing on data they've been collecting for a little while, and then they have a long machine learning kind of iteration process, typically spend over a few months to put new machine learning model into production, right? So these days, there's a new category of use cases coming up, right? So for example, account takeover, that's in the fraud detection, fraud prevention sort of scenario there, right? So what company used to do before was, really kind of relying on real-time detection based on rules, heuristics, right? So, for example, if this person try to log in from multiple IP addresses within, a certain amount of time, that's a rule you can simply, capture, right? But today, in today's world, there's just more data than you can possibly capture from a human perspective using rules. So people are more looking into using machine learning to do some of those detection as well, right? And as part of that, it really has an extremely high requirement around how do you process your data as a dependency for iterating your model, right? So so a lot of companies kind of look into how do you move from the simplistic, online, real-time, directly calling database sort of situation into, a little bit more complex, maybe, involving joins from multiple data sources, but require, that optimization and distributed processing that at company scale, right? So that portion is definitely kind of requiring company to move toward, move the mindset from, from batch processing into the real-time space. And also there's going to be a lot of, boundaries getting more blurred, right? So for example, between the batch side and streaming side, and also between, the streaming side is considered to be near real time, but also the boundary between the near real time database lookup, right? So all of those boundaries is going to get blurred. So I would say stream processing definitely going to kind of contribute a lot to the machine learning space as well.
Thanks. Any thoughts, Mike? Yingjun?
Yeah, I mean, I'm super excited about the intersection of the physical world and the digital world. It's our background in McLaren racing was streaming data from cars and processing that. And I see more and more need. I think we all know this kind of big data trend curve that projects out into the future at, zettabytes of data per year. A lot of that is being driven by IoT applications, like physical things creating data. And when the data gets that big and fast, the only real way to handle it is with streaming, and a lot of that is with machine learning. There's just too much of it. So the confluence of machine learning and streaming is super cool. Having said that, we also see a lot of use cases where people are deploying physics logic to process this data, because it is at the end of the day, IoT is physical systems. So the data can be described and modeled nicely using physical first principles, and often what we see is maybe a mechanical engineer could build a physics model. I think the marketing people might call this a digital twin, and process that data with some first principles logic first, and then move on a maturity journey towards machine learning. And that's probably another thing that we see a lot of, is that people want to do machine learning, but there's stepping stones to get there. As we just heard, often you do it with rules or logic. In the physical domain, you can also do it with physics, and then maybe you start, to upskill and go into machine learning. But that's predicated on you collecting high quality data, because we know like most of machine learning is good quality data, right? And a streaming system is also going to help you collect good quality data. So we've worked with clients who've come to us and said, hey, yeah, we want to build a machine learning pipeline for X. And actually they've built a data ingestion and data collection pipeline first, collected data for sometimes, months or even a year. And then they're able to train an ML model and deploy it. And that sort of like training, testing and deployment phase becomes a lot easier because they have spent time collecting very good high quality data in a streaming platform first. So I think the two things are very complementary. But not to say you don't have to rush towards machine learning. Take one step at a time, upskill yourself in your business, and then you'll move naturally in that direction.
Any thoughts?
Yeah, so definitely, so in terms of the use cases, machine learning is definitely one of the major use cases. So I have to admit that I'm not a machine learning expert, okay? So, but we did have talked to several machine learning companies. Well, not machine learning company, but yeah, machine learning teams that they want to use RisingWave as a feature store. So basically, their use case is more about the online transformation, right? Transform the data at a real time, and so definitely that's one of the main use cases. Just to think about the ads, right? But just to think about ads recommendation, just to think about the fraud detection, right? So these are definitely use cases. And in terms of apart from the machine learning, well, we have already seen the use cases in the entertainment, in the manufacturing, in yeah, fraud detection is definitely another one. I mean, not machine learning fraud detection, but fraud detection. Fraud detection is definitely another one, and also fintech. Fintech would the Web3 and the Web2. The stock option fintech and the Web3 fintech. So definitely, well, these are use cases. And actually, surprisingly, well, I mean, probably it's not quite surprising if you can see that fintechs have the needs, right? So they probably want to do stream processing, and they probably need to monitor the stock markets, right? Definitely, that's the use cases. But but which surprised me is that essentially some manufacturing companies also have that need. Essentially, for example, they are probably manufacturing some devices, right? They are building some devices, and essentially they have the need to monitor their factory and see if there is any accidents happening there, and if there's any anomaly happening there, right? So which makes us pretty surprised, and also we are seeing that people are moving from batch to stream processing. In that, well, they feel that the data volume increases. So I can give you an example. So for example, ride-sharing company collect the data from every single day, right? So actually every single second, right? So they collect the data. And conventionally they need to dump the data ingest the data into their data warehouses and then process the data. So their latency, the latency is around probably 30 minutes or probably 1 hour. But as the company grows, they need to collect more data. They have to ingest more data into a data warehouse and do the processing. What they will find is that originally we can process data within 30 seconds, within 30 minutes, but now it's not possible. We probably need to take much more time, and that actually makes them to think about, okay, if we should convert from batch processing to stream processing. So definitely, well, I think, well, that's definitely a trend, right? Because, well, anyways, well, no matter how bad the economy is, well, the companies will still collecting the data. If they collect enough data, they will find that dumping all your data into a data warehouse and then do processing is not enough. So yeah, these are the use cases I've seen over the last several months. Yeah.
Anyone wants to add something, or we will slowly wrap up? We have some questions to be answered. Any final words before we move to the questions?
Final word, it's exciting era for stream processing for sure.
Yeah, I actually saw that there are several questions in the Q&A, right, from the chat box.
Yeah. Can you see the questions? Anybody wants to go
On
first?
the topic of
We have 2
GitOps.
questions already. Yep.
I think the GitOps, who can answer the GitOps question?
Who wants to go with that one?
I guess it depends.
Yeah.
Well, I can answer in our context. I think there's probably a different context around Flink implementations or other ones. Yeah, with what we're trying to build with our new open source project, your code it's just code, right? So it lives in Git, and you got to deploy it into Kubernetes. So you need, a CI/CD process. Yeah, we're leveraging Git quite heavily in order to manage. It's best practice in software development to leverage Git and CI/CD to move code from dev, to staging to prod. But the cool thing is if you've got a unified stream processing platform, when you move your code, you can test it at every stage. So you can replay data through your pipeline as if it were live data to test, to automate the testing of your pipeline. You can do that in a dev environment. When you move using GitOps through to staging, you end up automating some of that, you know, with bigger workloads, more data flow. And then obviously you go into production. So absolutely, I think you know, GitOps and CI/CD and testing really become a part of the toolkit of data engineering and data scientists, and that's probably a big part of things that people need to learn at the moment. If the data scientist or is working in an offline environment, that they're probably not that familiar with some of those best practices of the software engineering domain, and that's kind of the exact things that they need to be learning in the next year to help them in the new world of moving to stream processing.
Thanks,
Now
Mike.
that might be completely different in the Flink world, so it'd be nice. We heard a little bit about Flink and GitHub earlier. What was that?
Yeah, so I think
yeah,
the GitOps thing is very important, I think, to a lot of potential users for stream processing. There's a couple of things we notice, right? So one is, as you know, developers, you know, especially the type of persona who's not like a software engineering or infrastructure engineering sort of role, for example, data scientist that wants to kind of tap into using stream processing, they type in code, right? They're using the abstraction layer, all that kind of stuff. But sometimes, you know, it's important because, you know, changing a feature in production is very, very important to the rest of the team member. So they want to have this process of approving, having at least, you know, eyeballing the results. So that's the first step, right? So, you know, leveraging GitOps, using that approval process is something, you know, a lot of customer potentially wants for that, you know, essentially being able to declare, making changes, go through the approval process, and then, you know, deployment into the Kubernetes cluster will be automated afterwards, right? Then after that, you know, there's also going to be, you know, maybe before the approval process that also kind of needs to go through unit tests, integration tests. I think there's nothing new than, you know, the traditional DevOps approach that kind of goes. These days, you know, there's also something called machine learning ops, right? So it's exactly the same approaches, just kind of used in different scenarios. So I feel like, you know, those standards are already there. It's helping a lot of teams in terms of kind of delivering fast, improving their quality. So I do think, you know, that's a very important thing, you know, for machine learning to also embrace that as well.
Yingjun, I'll skip you on this one. We have two more interesting questions.
Yeah, let me answer the let me answer the second question. Okay, so what you see as a major challenges to implement stream processing? Okay, I think the question itself is kind of confusing. Well, implementing stream processing engine or implementing stream processing application, right? So if we are talking about implementing a stream processing engine, then I think the major challenge here that, okay, so how do you balance between the cost and the performance? So for now, well, I mean, we are implementing the so-called decoupled computing and storage engine, right? But well, it's not for free, right? Well, it's not a free launch, right? Because well, you have to store your data in your S3, which can be a slow, which is essentially a slow storage, right? You need to think about, okay, how to balance the performance and the cost, right? But in terms of the stream processing, application, what we found here that the main challenge here that is more about the people's mindset. A lot of people think that well, we have already used Hadoop, or probably we have already used Spark, or we have already used a Snowflake for a while, or Redshift for a while, right? Why do I need stream processing, right? It's the question is more like that, not about okay, how difficult it is to implement a stream processing application. So I think here thing. Well, I mean, if you're trying to actually, this question is also similar to the third question, right? Well, how can the data leaders better support their teams to create a streaming first mentality, right? So I mean, look, well, so I have to say that stream processing is not for free, right? So it's still actually I mean, you still have to, I mean, if you already have your batch processing stack, you probably still need to build a new stack, right? And people are always reluctant to adopt new technology, and always reluctant to migrate data, right? But what you can tell them is that, okay, sure, look, well, I know that case, it's hard to, it takes time to migrate data or to adopt a new stream process, new technology. But think about, well, what if the data volume increases in the, right? As our company will grow, right? Our company will grow, we will have more data, right? If we have more data, how can we ensure that, okay, we can still have fresh results, right? And fresh result actually means a lot. Think about the fintech. If you get a data within, let's say, just a few seconds, that can make things quite different from, okay, getting the results within, let's say, 1 hour or several hours, right? In terms of manufacturing, right? If I found some accidents, I just want to stop the machine immediately, not to stop the machine, let's say, 1 day later, because, well, if I stop the machine 1 day later, then probably I have to produce a lot of trucks, right? So doesn't really make sense, right? So that's why you have to tell them that, okay, you have to tell the team that the benefits, which is more about the freshness, the data freshness, also about the if the data volume increases. What about the right?
We're running out of time, but would
Yeah,
any
sure.
of you try to answer these 2 questions? I love the third one.
Yeah, I can quickly comment on the last question. I think the last question is super interesting to me as well, right? So I have a couple of recommendations. One is, as a leader of the organization, right? So trying to figure out the data strategy going forward, I think, it's important to kind of paint a picture about return on investment, right? So I think, from 2 different kind of dimensions here. One is, how does move from batch processing into stream processing, or maybe having that lower latency impact your business, right? So we have looked at some of the companies that, in specific verticals like fraud detections, all that kind of stuff, right? We've seen even just you move producing data from batch, like from hourly batch to, a stream processing, which give you lower latency and higher freshness, like in terms of minutes, that bump use cases in certain scenarios, like the bot detection, for example. We've seen some company like LinkedIn showing a 30% improvement in accuracy, right? So imagine how much money that can save you, right? So that's for the benefit side. On the other side is also, you have to look at your existing architecture. Today, a lot of companies still using, Lambda architectures and Kappa architecture, maybe, for some of the companies. And having that architecture is going to actually prevent you from moving stream processing, because you have 2 technologies available. I'm not saying you have to pick one or the other, right? But it's more about, how do you look at, invest enough into the abstraction? Because a lot of companies don't see the value in investing that, because they don't tie that directly to how they see the end of business results, right? So looking at maybe painting a clear picture to developers in terms of how the architecture evolve, evolution is going to look like, right? Maybe leveraging some of the cloud vendor solutions like RisingWave, or us, in the future, can help with some of those things in terms of kind of improving architecture, right? So I think that's one, in terms of kind of having a clear picture on ROI. The second thing is really about, painting, giving that mindset and give that safe environment to developers, right? Because moving from batch to streaming is not going to be smooth. It's not just the migration, right? It is going to be that mindset. You have to shift it from, business hour on-call to maybe 24/7 on-call, right? So things gonna break down more often just because of the nature, things are flowing constantly. And you really have to train your team, to be more operationally ready, but also having that mindset, when things goes down, it's not the team's fault. We have to kind of build this together, and that takes time. So that would be my recommendations.
Mike, any thoughts, or we are wrapping up?
Yeah, you got to get it right. Pick off the high value, the high business value use cases first, build a spike, get something into production, and then start moving from there. I mean, the reality of business infrastructure is that it's incredibly complex. You've got many, many different technologies. And so you got to create a migration plan, picking off the high value for your business use cases first. And I think actually we live in a world where there's an insatiable appetite for like on-demand and highly responsive applications. And so there's lots and lots of use cases for real time, but just figure out where there's the most customer pain and solve that using a streaming pipeline, and then start the migration from there.
Anything to add? If not, I would like to thank you for participating. Also for everybody who is attending, we will be sending this recording. Thanks again. This was so much fun. We should like do this thing like sometime soon again.
It is a lot of fun.
Yeah,
Thanks for
super
inviting
cool.
me.
Thanks.
Thanks everyone.
Thanks everyone.
Bye, guys.
Bye.
Bye.
Bye.